Hello everyone, I'm Frank and welcome to episode 60 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. Today's puzzle is called White Dots by Sudoku Explorer, and here are the rules. Normal Sudoku rules apply. Place the digits 1 through 9 in each empty cell. Digits must not repeat within the same row, column, or box. White dots. Digits separated by a white dot are consecutive. Not all dots are given. And these are, there's another name for these are called white Kropke dots. I'm not really sure actually where Kropke comes from, but that's what they've been named, so I follow the convention. As an example, if this were, say, a 6, this would have to be a 5 or a 7, because white Kropke dots separate digits that are consecutive. And those are actually all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. So let's learn how to Sudoku. Okay, first thing first that I see, we have a 1 here, and it's next to a white Kropke dot, so the next digit there has to be a 2, which means the next digit after that has to be a 3, because we already have a 1, and the 2 can only be consecutive with 1 and 3. Similarly, this 3 can only be consecutive with 2 and 4, so this must be a 4. Which means... The next question is, where can 1 be in this box? Because 1 only can have one digit that it's next to. So it cannot be here, cannot be here, cannot be here, because those all have 2 unique digits that it's next to. Can't be here, because again, it has 2 unique digits that it's next to, right? This one is consecutive with this and this. This one's consecutive with this and this. This one's consecutive with this and this. This one's consecutive with this and this. So where is the 1 have to be? It has to be here. And again, while it's consecutive with 2 digits, they could be non-unique. And in fact, they have to in this case, because there's no other place in this box to have a 1. Can't be any of these 3. And again, this sees 2 unique numbers, which are consecutive with it. This one also sees 2 unique numbers because they're unique because they're in the same box. So similarly, these are unique because they're in the same box. This one sees these 2, which are unique because they're in the same box. And this one... Oh, wait, I guess this one could be a 1. Okay. That's not necessarily given. Interesting. But if this were a 1, right? If this were 1, so this is next to only one unique number, but if this were 1, this would have to be 2, and that's not allowed because the 2 cannot be there. Therefore, okay, so my previous logic was correct, but the problem is that I didn't go through the whole steps. So again, this is next to 2 unique numbers because they're in the same box. This is next to 2 unique numbers still in the same box. Same here. This is next to 2 unique numbers because they're in the same box. And this one's next to 2 unique numbers because they're in the same box. So none of those can be 1. 1 could be here, but then that forces this to be 2, and that's not allowed because the 2 is here. Therefore, the only place for 1 in this box has to be here. So this is 1, which can only be next to 2. So these are both 2. I'm sorry, consecutive with 2. And the white Kropke dot forces that, right? So therefore, this must be 2. Now, interestingly enough, the 2 cannot be next to 2 unique digits in this box unless it's with a 1 and a 3, and the 1 obviously is here. So the 2 cannot be, can't be any of these because of this 2, can't be any of these because of those 2, can't be here because it's consecutive with 2 unique digits, and one of them can't be 1, so therefore that can't work. This can't be next to 2 unique digits. Well, okay, so 2 can't be here. So the 2 has to be one of these 2 here. We could have actually just gotten that from normal Sudoku. Anyways. This 2 can only be next to 1 or 3, and if it's 1 here, this would have to be 2 also, which would break because of normal Sudoku rules. So this has to be a 3, which means this has to be a 4, because 3 is only consecutive with 2 and 4. And we already have a 2 in that row. Now, in this row, 1 cannot be consecutive with any other cell in this row, right? Because if 1 is consecutive with anything, it's with 2. So 1 cannot be either of these 2 cells. 1 cannot be either of these 2 cells. Now, if this were 1, this would have to be 2, and that would break because of normal Sudoku rules. So this is the only other place for 1 in row 7. That's possible. So this is 1, which forces this to be a 2. Where else can 1 be? 1, again, if it's consecutive with anything, it would have to be with 2. But we already have a 2 in this box. So 1 cannot be consecutive, cannot be next to a white Kropke dot in this box. Cannot be next to a white Kropke dot that is consecutive with something in the box. So 1 cannot be any of these. 1 can't be here and here because of these ones. So this must be the only place for 1 in this box. 2 has to be one of those. This cannot be 3 and 4. Where can 3 and 4 be? 3 and 4 can only be in these cells, right? So either this is 3 and this is 4. And this would have to then be 5 and 6 because those are the only forms that can be consecutive. So 3 cannot be in between 2 unique, cannot be consecutive with 2 unique cells in this box particularly because you don't have a 2 available. So 3 could be here or it's here. 4, either way, cannot be here, right? If this is 4, 3 would be here, and then what is 3 consecutive with? It can't be 2 or 4, so therefore 4 cannot be here. So 4 has to be one of these 2 cells. 3 has to be one of these 2 cells. So if this is 3, this would become 4, 5, and 6. If this is not 3, that's 3. This has to be 4, which makes this 5, 6, and 7, because those are the only possibilities for 3 and 4 here. So one of these is a 5, one of these is a 6. The remaining cells can be 7, 8, or 9. This could be 7, 8, or 9. And this could be... There's no 4, there's no 5, and there's no 6. So this can't be 3. This could be 7, 8, or 9 also. And we don't know what else is here. So 5 is here, which means one of the... Well, we don't know about this. This cannot be 8 and 9, because that eliminates all possibilities for this cell. Also, yeah, actually, once you start on 1, it will complete the other way around, right? So this could be 2, which would force this to be 3, which would force that to be 4. But that's not possible then because of this 4 here. So this cannot be the 2, which forces this to be 2. This can be one end, so it could be 3, 4, 5, 6, 7, 8. Or it could be the other end, which is 8, 7, 6, 5, 4, 3. Either way, these can't be 3 or 4. So if this could be 3, 4, 5, 6, 7, 8. It could be 4, 5, 6, 7, 8, 9. So if it's 3 through 8, this would be 9. If it's 4 through 9, this would be 3. Or it could be starting from 9, 9, 8, 7, 6, 5, 4. So this could be 9, 8, 7, 6, 5, 9, 8, 7, 6, 5, 4, and this would be 3. Or it could be 8, 7, 6, 5, 4, 3, and this would be 9. Okay. Do we have anything guaranteed there, though? No. So if this is 3, 4, 5, 6, 7, 8, 3, 4, 5, 6, 7, so then this would be 5 if that's the case. Because it can't be 7, but it's still consecutive with 6. If this is 4, 5, 6, 7, 8, this would have to be 6. Basically, this, whatever this cell is, has to be the same as this cell no matter what. Because the other consecutive one is here, so this has to be the same as that. So this is 5, 6, or 7. Oh, so we know 6 is here. This cannot be 5, anything with a 6. So it cannot be 5, 6. Cannot be 6, 7. It could be 7, 8, or 8, 9. So this has to be 7, 8, or 8, 9. Which means 8 has to be one of these two digits. So this can't be 8. It could be 5, 7, or 9. Because it cannot be 6 and it cannot be 8. 5, 7, or 9 are consecutive with 4, 6, and 8 only. So those are the possibilities there. These two are consecutive. 1 cannot be here. Cannot be 1, 2 because of the 2 here. Can't be 2, 3. Can't be 3, 4. It could be 4, 5, 5, 6, 6, 7, or 7, 8, or 8, 9. So that's a lot of possibilities. Where can 1 be, actually? 1 cannot be here in this box. 1 can't be any of these because they must be consecutive with something in the box, but the problem is that 2 is already in the box, so therefore that can't be 1. And if this were 1, that would be consecutive with only 2, but we already have a 2 in the column. So 1 cannot be any of these, therefore it must be here. So this is 1. 1 cannot be here. 1 cannot be here or here. So 1 is either one of these two. And if this is 1, this would have to be 2, which is breaks the normal Sudoku rule. So therefore this must be 1. So this is 1, which makes that a 2, which makes that a 3, because again 2 is only consecutive with 1 or 3, and 1 is ruled out here. What else do we have here? This is 2. 3 cannot be here. So 1 has to be one of these two in this box. 1 has to be one of these two in that box. And this one could be many things. But it cannot be here. Because if this is 1, that would be 2. So therefore that doesn't work. So one of those 3 is a 1. What about 2s? 2, again, can only be one of those 2 cells. Well, 1 can only be in those 2 cells, and 2 can only be in those 2 cells, which means this has to be a 1-2 pair here, specifically. Because there's no other place for the 1s and the 2s, and they have to be in both of those, in those 2 cells. And so therefore, those 2 cells can only be those 2 digits. What about 2 here? 2 can be one of these 2 cells. And then it could be any of these 4. So that's kind of broad. 3 can only be one of these 2 cells. Where else? 3 can't be. Okay, so that's pretty limited. 4 is one of those 2 cells, so 4 has to be one of those 3 cells. Okay. Do we have anything else? 4 cannot be either of these cells. And because of that, 3 can only be consecutive with 4 in that box because 2 is no longer available. So 3 cannot be either of those cells. And if 3 were here, that would force us to be 4. So 3 can't be in this cell, right? So if this is 3, one of these would be 4, right? If this is 3, one of these would be 4, but the problem is that 3 cannot be next to 2 unique digits in that box because 2 already is taken. So 3 cannot be either of these cells. 3 can't be any of these by that digit. And 3 can't be here because that would force us to be 4. So 3 has to be one of these two cells in this middle box. Well, since 3 is one of those two cells in the middle box, that means the 3 cannot be in any of the rest of the row. So this can't be 3, therefore this is a 9. This can't be 3. Where is the 3 in this box? It can only be here. So this is 3, which makes this 4, which makes that 5, which makes that 6, 7, and 8. This 6 can only be next to 5 and 7, so this can't be 7. This has to be the 5. 3 cannot be here now in this lower left box. Where can it be in that box then? It has to be here. So this is 3, this is 4, this is 5, and this is 6. This cannot be 9 because of this 9. So one of these is a 9, which means this is specifically 7 or 8. The remaining digits here are 6, 7, and 8. And the main digits here are 5 and 9. So 5 and 9 are only consecutive with 6 and 8. So if this is 5, it has to be with 6, and if this is 9, this has to be 8. And those are the only possibilities there. This is 5. So none of these can be 4 either, right? If this is 4, well, none of these could be 4 anyways. If this is 4, it has to be consecutive with 3 or 5, but they're both taken in that column. So 4 cannot be here. 4 can't be any of these cells, and if this is 4, this would have to be 3 or 5, but 3 has to be here, and 5 is already taken in the box, so this can't be 4. Therefore, where's the 4? It has to be here, which makes this a 3. This can no longer be 4. This can't be 8. This has to then be 6. And 6 is only consecutive with 5 or 7. So this is 5 or 7, but we have a 5 here, so this can't be 5, so this must be 7, which makes this an 8 and 9 pair. Remaining digits. This can't be 6. This can't be 7 either. And we already are limited for 1, 2, 3, 4, 5, so this must be 8 and 9. And 9 can only be next to one consecutive digit, so this can't be 9. So this is 9, which makes that 8, which makes that 7. This must be 6 then. 6 is only consecutive with 5 or 7, and 5 is already in the column. So this must be 7, which forces this to be 8. This 8 means this has to be 6 and 5, which makes this 9 and 7. This 7 means this can't be 7, so this is 8. These can't be 8, so this is a 7, 9 pair. This can't be 9 because of this 9, so this must be 8, which makes this not that, makes this a 9. Remaining digits here are 5 and 7. Remaining digits here are 3 and 4. So this is 3 and 4. This is 5 and 7. These are now 8 and 9. Okay. This, let's see. What are the remaining cells? 3 cannot be here. So the only place for 3 in this box is now here. So this has to be a 3. The 7 has to be one of these two cells in this box, because it cannot be here, and it cannot be here, and it can't be here. So 7 could be here. If 7's here, this has to be 8, which is possible. Okay, let's check out the remaining digits in this column. It has to be 1, 4, 8, and 9. Well, this can't be 4 or 8, so where is the 4 or 8 in this column? It has to be in these two cells. And this can't be 4, so this must be 8, which makes this a 4. This then has to be the 1, because that's the only place for it, and therefore this is a 9. So this can't be 1, this can't be 9, so this must be 7, which makes that a 9. 1 is one of these 2 digits. That's fine. Let's look at column 6 now. What are the remaining digits there? They have to be 2, 5, 6, and 7. Well, 7 can't be here. 7 can't be here. Where is the 7 in column 6? It has to be here. So this is a 7. And then we have 2, 5, and 6, which could be any of them. So this could be 2, 5, 6. Ah, but this can't be 5 or 6 here, so this must be a 2. Which means this can't be 2. So this is 5, 6, and this is 5, 6. Well, where's a 2 in this box? It can only be here now. So this is 2, and this is 5 or 6. And this becomes, well, no, this can't be 2 anymore. So what's the remaining digits here? It's 1, 5, 6, and 9. Okay. Well, this can't be 1, this can't be 9, and this can't be 5 or 6. This can't be 2 anymore, so therefore this must be 1, which makes that a 2. This 1 means this can't be 1, so this is a 9. Well, the only place for 1 now has to be here, so in this box. So this is a 1. This can't be 9. We now have a 5, 6, 5, 6 pair, which eliminates 5 and 6 from the rest of the row. So these must be 7, 8, and 9. And for consecutive digits, you have to have, it's either 7, 8, or 8, 9. So 8 cannot be here. 9 obviously can't be here. The remaining digit here is a 4, so there's a 4 here, which makes that a 3, which makes that a 4. Neither of these could be 4s now, so this must be a 4. The remaining digits here are 5 and 6. Remaining digits here are 5, 6, and 3, and this can't be 3, therefore this must be 3. So this must be a 5, 6. Well, now we have a 5, 6, 5, 6 pair in column 9, which eliminates 5 and 6 from the rest of the column. So this can't be 5 or 6, so it must be 7, which makes this a 9, which makes that an 8, which makes that 9, and this is just normal Sudoku. This 7 means this has to be a 5, which means this can't be 5. This is a 6, which means that can't be 6, so it's a 5, which means this can't be 5, so it's a 6, which makes that a 5, which makes that a 6. That makes that a 5, and that's a 6. And we're almost done. This can't be 7 or 9, so this must be 8, which makes that a 7. The remaining digit here is a 5, and the remaining digit here is an 8. And that's how you solve it. Yeah, actually, it's pretty interesting because it goes sort of into detail about how white crop key dots can work, right? And what limitations you can place with the white crop key dots. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.